All right, so we are good to go. So what we're going to be doing today is this is SPSS day. So we have made it to the point where, because what we are doing is what we are doing is now completely in the realm of what we do in real life psychology, that we now actually have access to a computer program that will do that for us. So we introduced the idea of the single sample t-test last class. Today we're going to continue our look at that single sample t-test just to make sure that, continue our look at that, but this time we're going to introduce SPSS. But before we get to that, just a very brief mention. So exam number 2 has been sent back, and we're not going to do the live in-class take-up of it today. We're going to do that when we get a chance, but today was just so important to block off some time for SPSS that I didn't want to risk it today. But I do just want to kind of give you a little feedback in terms of the progress. So this is, once again, a frequency distribution. Here are the possible scores for exam number 1. Here's the frequency of students that scored each possible score in exam number 1. And I just kind of want to show you the progress that we've all made in this class. So this is the grades on exam number 1. These are the grades for exam number 2. So you can literally see the learning outcomes occurring. You can literally see things snapping together and making sense for individuals. You can literally see that everybody has basically moved up for exam number 2, which is an awesome thing to see. And for those of you that are making this transition, you can also see, and this is true of statistics exams especially, the mode here, the most frequent score was between 90 to 99, seconded only by the 100%. So it is massively possible, and in fact, it's probably going to become the mode for exam 3 and 4 to get 100% on these exams. So just to let you know, a little bit of encouragement, we are doing very well, and I expect this graph to just keep moving for exam 3 and then the final exam. All right, so for today's class. So last time, we introduced the idea of the fully functional real-world t-test that we were going to do. And as you saw in the calculations, it was starting to get a little complicated. There was a lot of steps that we needed to do. And in reality, we even skipped over some of those steps because we weren't looking at raw data. We already had that descriptive data. So we are getting now to the point in statistics where it's going to get rather difficult to do all of these things by hand. So it's the perfect time to introduce SPSS, to introduce this new tool that is going to unload all of those, let's face it, menial calculations that we need to do, and hand that over to the computers, let the computers do what the computers are good at. And then on us, it's going to fall the responsibility of doing what we're good at, which is that rational thinking. Which hypothesis test should we do, and how are we going to interpret that output? So that's where we're going to shift our focus on right now. You've taken a look behind the curtain enough. You've taken a look at the gears of statistics enough right now. So we are going to focus, now that you kind of know what's going on behind the scenes, we're going to focus on the different hypothesis tests and doing the work that determines which test you're doing, and then how do you interpret that output. So one more time, we're going to go back and visit Harlow and his monkey studies. And this time, we're going to start it from where Harlow actually just has the scores for each of his monkeys. So instead of any summary data, any sample mean whatsoever, we're going to go all the way back to Harlow being handed that piece of paper by his research assistant that said, monkey number 1, 12.2 hours with the terry cloth mother. Monkey number 2, 10.6 hours with the terry cloth mother. We're going to see how we go from that data to our hypothesis test. All right, so hypothesis test with the t-statistic. We are going to introduce SPSS, and then we're going to have time for in-class practice, just so that you can play around with SPSS a little bit more and get that familiarity. So before we launch into this, just one last time I want to remind everybody that you have resources available to you for when you're trying to do this at home. So if you're working on your stats homework, your pre-test, your post-test, whatever it might be, here at IUSB, your computers will have, especially here in YCamp, they will have SPSS loaded onto the computer. So we'll see that today when we access SPSS on these computers. But you also have options for that at home. So if you haven't already, you can actually install Excel at home on your computer. You can access Microsoft Office and get the license as students of IUSB. And you can also access SPSS from home, but I want to be very clear, you cannot install it on your home computer. What you can do is you can have that cloud access that you have through IU Anywhere. So just bear this in mind. If you try to install it on your home computer, you're going to be asked to pay for a subscription fee, and that would be like, I think it's $60 the last time I checked. Just want to make sure that you know you do not have to pay that to get access. All you need to do is install IU Anywhere on your computer, and then you can go to the IU Anywhere login page for OneIU, search for SPSS, and you will find two versions actually, 24 and 25 of SPSS. Either one is good. Either one you'll be able to do your homework and your pre-test and post-test with. But just want to make sure that nobody's going out there and buying that subscription when you don't have it. Alrighty, so with that taken care of, let's go back to that infant monkey study. So we've seen this a few times by now. Two surrogate mothers, one made of terry cloth, one just wire mesh, but it has food, it has milk. Which one will the monkey choose? So what we know is that in a typical day, the infant monkeys, they spend a total of 18 hours clinging to one of the two mothers. So we could get this from studies of monkeys in the wild. We could get this from observing monkeys in the laboratory. We just know, we have this information, that monkeys spend 18 hours a day hanging on to one of the two mothers. And this is by far, this little step here is by far the most challenging aspect of the t-test that we're doing right now, and that is figuring out that hypothesized mean. So the hypothesized mean is not always going to be given to you, but you will have enough information to determine what your hypothesized mean is, and that information, or the mean that you're looking for, is what would you expect the mean to be if there was no effect. So if your null hypothesis was true, what would you expect that mean to be? And if it helps you, think about this example right here. This is a very clear topical example. Pay gap in 1970 was 41 cents. Pay gap in 2016 was 21 cents. What's the pay gap in 2019? I don't know. We don't have that data yet. But we do know if the null hypothesis was true, that is, if it was true that there is no pay gap, then the hypothesized gap would be 0. So look for that information in your question. It will always be there. And think to yourself, if there's no effect, if there's no preference, if there's no difference, what would I expect that mean to be? So we have that here in this question here, where in this situation, where it goes, these monkeys spend 18 hours a day with either of the mothers. So if there was no preference between the two, then they would split that time right in half. And we know that if we are dealing with monkeys that have no preference, 9 hours of the day they'll spend with the terry cloth mother, 9 hours of the day they'll spend with the wire mesh mother. So just be clear on that, because oftentimes I find that where students get tripped up on this is exactly finding that number. And look for those instances where they'll say, oh, they spend 18 hours and they spend it between two mothers. And then ask yourself, if there's no preference, how much time would they spend with each one? In this case, that's where we get that mean of 9 hours for each one of the mothers. So what we find is that actually the typical monkey spent around 15 hours per day with the terry cloth mother. So we have a sample of 9 infant monkeys. They averaged 15.3 hours a day with the terry cloth mother. And we're going to now run this t-test one more time to determine, is this result sufficient to conclude that these monkeys actually spend significantly more time with the terry cloth mother? I.e., does this sample of monkeys not belong to that no preference population, right? So they're too weird to have belonging to that no preference population. It must be that they came from a population of monkeys that prefer the terry cloth mother. We're going to do a two-tailed test with alpha of 0.05. Alrighty, so once again, very nicely, we're doing it by pencil and paper before. We had a 5-step procedure. Now we're doing it with SPSS, same 5-step procedure. So some of these steps now are going to be handed over to SPSS wholesale. Some of them we're still going to have to do completely on our own. Some of them SPSS will help us out on, but we're still doing those same 5 steps. All right, so let's get going on this. So one of the steps that SPSS will not do for us at all is the null and the research hypothesis. That is still completely up to us. So we still need to restate the question as a null hypothesis and a research hypothesis. So is there a preference for the terry cloth mother or for the wire mesh mother? That's the question we ask as psychologists. We formulate that as a research hypothesis, that there is a preference for one of the mothers, which means that the mean time that they spend with the terry cloth mother does not equal the mean time that they spend with the wire mesh mother. And for SPSS, we need to define what that mean time is. So in this case, if the mean time with the terry cloth mother does not equal the mean time with the wire mesh mother, that means that they did not split their times evenly. That means that they did not spend equal amount of times with the terry cloth and the wire mesh mother, which means that they did not spend 9 hours with one mother and 9 hours with the other. So we rewrite this as the mean time spent with the terry cloth mother is not 9 hours. Maybe it's more, in which case they prefer the terry cloth mother. Maybe it's less, in which case they prefer the wire mesh mother. Either way, if it's not 9 hours, they're in that treated population, the population that prefers one of the mothers. The null hypothesis, on the other hand, is that there's no effect, there's no preference for either mother, which means that the time spent with the terry cloth mother equals the time spent with the wire mesh mother. And again, this is oftentimes the most challenging steps for students when they start off this single sample t-test. How do we get that number? And it takes a little bit of logic, it takes a little bit of deduction, it takes reading the question. And in this case, realizing that they spend 18 hours a day with a mother. And if there's 2 mothers to choose from, and they don't prefer either one, they're going to split those 18 hours in 2, and they're going to spend 9 hours with the terry cloth mother, 9 hours with the wire mesh mother. So that is the unknown but hypothesized population. So are they from the population of monkeys that spends 9 hours a day with that terry cloth mother? All right, so that's step 1, all on us. SPSS is not going to do that for us. Step 2, determine the characteristics of the comparison distribution. Very nicely, SPSS will do this for you. So SPSS will do basically chapter 6 for you. It will calculate out what your comparison distribution is. That's all going to be on SPSS. Step 3, set a cutoff sample score or critical value. SPSS is going to do this as well, sort of. All right, so we're going to talk about that sort of in just a moment, but we're going to see that SPSS will actually set a cutoff score for you, and we'll see what that is in just a moment. Determine your sample score on the comparison distribution. SPSS will do all of this for you. So step 2, completely done. Step 4, completely done for you. Step 3, kind of halfway there. SPSS will do those for you. So we promised enough. Let's go actually see how SPSS will do all of this. And what you're going to want to do, if you haven't already, we are going to use data, and that data can be found in Excel sheet number 22, practice, March 21st. That should be in your Excel practice sheets. And so if you haven't already, please open that up. And while you're doing that, I'm just going to mention that this is going to be videoed. This is going to be posted on YouTube as well, the kind of steps for this. However, because we're in this room, we're not going to have that nice kind of dual screen setup that we normally have. But just to make sure that you do have access to this, when I was doing this, preparing the lectures, I took screenshots of literally everything that I did. from accessing SPSS all the way to entering and choosing the correct test to do. So you have screenshots there in your lecture notes, and we are going to start doing this live and in person right now. So the first thing to mention, and I'll just zoom in here. The first thing to mention is when you can use SPSS. And the one rule in terms of when you can use SPSS is you need the raw scores from every single subject. So you remember before, when we were doing this test, we only had the mean and the sum of squared deviations. So last class, when we introduced the t-test, we started with the mean and the sum of squared deviations. That's what was given to us in our question. With just that information, we can't use SPSS. SPSS requires that you actually have the raw scores for your subjects. So here we have the raw scores for the 9 monkeys. Monkey number 1 spent 17.2 hours with the terry cloth mother. Monkey number 4 almost spent the whole day with the terry cloth mother, 22.89 hours. Monkey number 9 only spent 7.71 hours with the terry cloth mother. But it's very important to realize that we need those raw scores for each subject. Otherwise, you just can't use SPSS. All right, so once you have those raw scores, once you know that you are good to go in terms of using SPSS, what we can do then is actually start it up. So what you can do, and hopefully this will pop up, just type in SPSS. Boom, there it is. Type SPSS in the search bar for the programs. IBM SPSS Statistics 24. This is the 24th iteration. In IU Anywhere, you will also have access to the 25th version. There are very minor differences between those. There's no surprise. Statistics really hasn't changed in a year. So anyways, we're going to click on that, and we're going to let it load. And we're going to get to this welcome screen right here. Yeah, let's do that. All right. So we got this welcome screen right here. Is everybody at this point? Everybody's got SPSS open? Oh, it's just loading. Does everybody at least have it loading? Okay. So a couple of things to point out here. Number one, this is your kind of landing page. This is the sort of wizard that pops up at the beginning when you load SPSS. It's got a lot of features that are really, really nice. So for example, you can load or you can start a new data set or a new database query. You can open other files. That's very helpful if you're working on a project that's huge and you've worked on it, then you've saved it. You can reopen it. You can start up wherever you need to. But the one that I want to point out with for you is that SPSS has a ton of help that comes along with the program. So if you are working on your homework and it's 2:30 in the morning, it's not going to be a surprise. Send me a Canvas message at that time. I'm not going to answer it in a timely fashion. But you still can get help. So right here on this landing screen, right here when you open it up, you'll notice here, get help and support. This is in case SPSS is doing something technically incorrect. But even better, it actually has tutorials built into the program. So if you need to know how to do a t-test for a single sample, if you need to know later on how to do an ANOVA, if you need to know how to, save an output, you can go to those tutorials as well. And then the last thing that I'll mention is that SPSS is one of the most popular statistical programs in existence today. And what that means is that you will find a ton of online resources, step-by-step videos for how to do SPSS. So once again, if it's 2:30 in the morning and you have been, and you forgot your phone, at somebody else's house, so you can't log into Canvas, and you're just sitting there going, I don't have access to my, files, I don't get access to anything, but I still got to do this statistics test. If you just Google SPSS and then the test that you're looking for, you will find tons of videos on YouTube of the step-by-step in order to do this. So you can use this, and I encourage you to use this as often as you need to. So for example, if you're doing your homework and you just forgot how to do a test, and for whatever reason you can't access the files, you can Google SPSS t-test single sample, and videos on how to do it will will pop up. You can do this for your pre-tests as well. So in your pre-test going forward, you will be asked to do statistical tests. You know, can you do an independent means t-test? Can you do a one-way ANOVA? And it's completely fine if you say to yourself, you know what? I'm going to do this pre-test, but I'm going to check out this video so I can use SPSS rather than doing it pencil and paper. Feel free to do that as well. Tons of resources on SPSS. It's one of the things I really like about it. Very widely used. Now, that being said, we're not going to use this landing page. So we're going to press close right there. And we are going to get to the actual program, which is right here. So one of the other really nice things about SPSS is that it is built a lot like Excel. So you will notice that we have our first page here. This is the data view. You'll notice down here, we got these two little tabs here. This is the data view. This is where you put your raw data. This is the variable view. This is where you can deal with your variables. Data view works a lot like Excel. So you see we got rows, we got columns. It uses the same copy and paste commands. So Control-C for copy, Control-V for paste. So use that when you're working on it. You can import a lot of the stuff that you use in Excel. All right, so is everybody here? Everybody at this stage right here? Okay. So first thing we got to do, we need some data. So what we're going to do is we're going to take this data right here, and we're going to copy and paste it into SPSS. So what we're going to do is we're going to highlight the raw scores, and we're going to highlight only the raw scores. And this is very key. Do not highlight terry cloth. Do not copy and paste the word terry cloth. Only raw scores go into the data set. Only raw scores go into the data editor. So we're going to copy and paste those. We can hit Control-C to copy it from Excel. And then we go back to SPSS, and we can hit Control-V, or just go up here, edit. We can paste it right there. You'll see the keyboard shortcut, same as before. We hit Control-V, and we've copied and pasted our data, our raw scores, into SPSS. All right. So, has everybody got their scores in SPSS? You good so far? Okay. So I'm going to mention this over and over and over again. Hopefully you'll get sick of it, because it's the most important organizing rule for formatting your data in SPSS. So it's kind of simple right now, because we only have one sample. So there's only one place to put the data. You got to put it there, row 1, column 1. But as we go on with more complicated hypothesis tests, we're going to have to make decisions as to where we paste our data. And the biggest help that you can have in organizing your data is to remember this one key rule, and that is that in SPSS, each subject gets one row and only one row. So every single subject gets a row reserved for them, and any scores that they have to go into that row. So here we have our 9 monkeys, and monkey number 3 goes into row 3, and that is monkey number 3's row. So we currently only have terry cloth hours recorded for monkey number 3, right? We've only recorded that this monkey spends 20.99 hours with the terry cloth mother. But if we also recorded the monkey's sex, and the monkey's weight, and the monkey's age, and the number of bananas that that monkey eats per day, and how long it spends on the tire swing that's in the cage. If we put all of that data into this data set, every single score from subject number 3, from monkey number 3, would go in row number 3. So just remember that. I'm going to mention it over and over again. Each subject gets their own row and only one row. So everything from monkey 3 goes into row 3. Every score from monkey 6 goes into row 6. And monkey 8, their scores go into row 8 and nowhere else. And nobody else's scores get to go into row 8. All right, so we have all our numbers, all our raw scores into those rows. And you'll notice that SPSS has given this variable a name. So if we look up here, you can see that SPSS has called these scores var0001. And var0001 is an excellent name for a variable if you're a computer, right? If you're a robot, var0001, that works, right? You'll remember exactly what that is. That's a horrible name for humans. And do not think for a second that if you were doing an actual experiment and you stepped away from this project for a day, came back the next morning, you would at all remember what var0001 was, what var0002 was, what var0003 was. You forget. It's a horrible name for humans. So because of that, we're going to have to change it a little bit. So we are in data view right now. We're going to click right here on variable view. And if you click on variable view, you're going to change to where the variable view is. And you can see right here that SPSS has given your variable this name, var0001. Great name for a robot, horrible name for us. So we're going to click on that, and we are going to change it. And we're going to change it to tear cloth. All right, so we change it to tear cloth. We hit enter. We go back to data view. And you'll notice that SPSS has changed the name of that variable to tear cloth. And that's a good name for us, because if we come here the next day and we say to ourselves, oh, what were those scores again? Were they time with the wire mesh mother? Were they the time with the tear cloth mother? Was that the weight of the monkeys? Oh, it's called tear cloth, clearly terry cloth mother. Now, I'm going to mention a few things about SPSS. I love it, but this is the 24th iteration of SPSS, and sometimes it shows the hidden layers underneath, and they pop up in weird ways. So this is one of those ways. You might be sitting there going, well, why don't we call it terry cloth? Right? You might be sitting there going, why don't we say terry space cloth? You know, keep it nice and English. Well, as soon as I put in a space, SPSS gets a little angry at me. And it says, no, that contains an illegal character. So one of the first things to realize is that SPSS oftentimes gets a little touchy. All right, that's the best way I can describe it. So in this day and age of using computers, the fact that you cannot rename something to have a space, I cannot remember the last time that has happened outside of SPSS. But you got to remember, this is the 24th version of SPSS. That means that it's been built up on versions going back all the way to the 90s, when you couldn't name files longer than a certain number of characters. So that's kind of carried forward in kind of weird places. That's kind of carried forward in something like here where you can't use a space. So this variable name contains an illegal character. You cannot put spaces into your names. If this pops up, just click OK, apologize to SPSS, say I didn't know, and name it something else. Other weirdness. You cannot start a variable name with a number. So if you have first group, second group, third group, you cannot call your variable one group, because SPSS is going to get angry and say variable name contains an illegal first character. So again, if that pops up, just say, all right, sorry SPSS, I'll try again. And the last thing that I'm going to point out is that we didn't call this terry cloth. And the reason for that is because terry cloth is 10 characters long. And if you stay 8 characters or less when you name your variables in SPSS, it will work throughout the entire SPSS program. So if you keep your variable names to 8 characters or less, you are guaranteed 100% of the time SPSS will not throw a fit when you try to analyze your data. However, if you go beyond that 8-character limit, it's going to work most of the time. It's going to backfire some of the time. So if at all possible, if it still makes sense to you as a human, do not go to overly long names. We could do terry cloth, it would work, but let's get into that good habit where we say, you know what, I'm going to keep it eight characters or less. You can imagine, this is like the 1990s version of Twitter, where you could only tweet 8 characters. All right, imagine you were trying to converse with SPSS. You can only tweet 8 characters. We're going to call it tercloth, Tercloth. We're safe. It'll work. And that's our naming convention. So just bear that in mind. If SPSS gets angry at you, read the warning, and you'll be able to very easily figure out what it was that you did. All right. So now we have our data in there. It's named in a way that we will remember what that data is. So now it's actually time to do the test. So for the test, you'll notice that there are tons of things that SPSS can do. And what we're going to be working with is this one here for analyze. So all of our tests that we're going to use is going to be there in analyze. And more than that, we're going to go down here to compare means. And all of the tests that we're going to be doing in this introductory psychology course, stats course, is in that menu. So go to analyze, go to compare means. That's where we're going for the rest of this semester. And then what we need to know now is which one of these, which one of these are we going to choose? So when we're deciding which one we're going to choose, sometimes SPSS is very friendly. Sometimes SPSS is not so friendly. This is one of the cases where SPSS is friendly. So we are doing a single sample t-test. And we are looking for something in SPSS that is the equivalent of single sample t-test. And when we scroll down, we see this thing called a one sample t-test. So again, that makes sense to our human minds. Single sample t-test, one sample t-test, same thing. SPSS is being very friendly. So that's the one that we want to click on. So once again, you start at analyze, you go to compare means, you go down to one sample t-test, you click on it, and then the one sample t-test window pops up. All right. So this is your one sample t-test dialog box. Is everybody at this point right now? Everybody here? We're all good? Okay. So here on the one sample t-test, you'll see that we have our variable in this window. This first window over here is going to hold all the variables that you have in your data set. So once again, we're keeping it simple. We only have the one set of raw scores. But again, if we had weight, height, age of the monkeys, all of those would be listed in this first box here. But we only got the time that they spent with the terry cloth mother. SPSS is asking you with this empty window over here, what are your test variables? What that means is what are the raw scores that you want me to test, right? What are the raw scores you want an answer about? What are the raw scores your hypothesis test is about? And the raw scores is this terry cloth one over here. So what we do is we highlight that, make sure that it's yellow, and then using this arrow, we pop it into our test variables. And if we make a mistake and we want to pop it back out, we just press that arrow again, and send it in, send it out, put it in, out, in, out, in. We can do whatever we want, but we want it in there. That's our test variables. So you're looking for the raw scores. The raw scores are your test variable. That needs to go into that window right there. And then the last thing, the most important thing, the thing that 99% of the time, if a student does an error on the single sample t-test, it's going to be right here. This is the most important thing to remember, is that the final thing you have to do before you run the test is you got to set this test value right here. So that test value is what you are testing your sample scores against. So we have all of these scores in Terry Clock. We have this sample here that has a mean of 15.3 hours. And we are asking SPSS to compare this to a number. We are asking the SPSS to compare this to a hypothesized mean. And that hypothesized mean needs to go into the test value. So if we ran it right now, the question we would be asking SPSS is to compare this 15.3 hours, this mean for our sample, to a hypothesized mean of 0. What we would be asking SPSS to do is to answer the question, do the monkeys spend more than 0 hours with the Terry Clock mother? Do the monkeys spend any time with the Terry Clock mother? Notice that's not what we're asking. If we go back to our null hypothesis, we're not asking, do they spend any time with the Terry Clock mother? We're asking if they prefer the Terry Clock mother. That is, do they spend 9 hours with the Terry Clock mother? So we got to change that 0 into a 9. We got to change that test value into the hypothesized mean. So we highlight it and we change it to 9 hours. So whatever you want to compare your sample to, whatever your null hypothesis is, that goes in that test value right there. And I'm making a big deal about that simple concept because so many times when students make an error on their one sample t-test, like I said, 99 times out of 100, I find out that their test value is incorrect. So the test value default will be 0. That is usually not the correct test value. And on top of that, it will remember your old test value the next time you do a t-test when you haven't closed the program. So when we do a second t-test, when you do your practice t-test, you're going to see that that test value is going to be 9 because it remembers your old t-test. But importantly, and again, I'm hitting this probably harder than you would like, but importantly, this needs to be your null hypothesis value. So we are comparing our Terry Clock times not to 0, but we're comparing it to 9 hours. That is our null hypothesis. All right, so does everybody got that information put in there? Okay, so we are good to go. So we have entered in all our info. We can now hit OK. And you can see in less than a second, SPSS has run our test. SPSS has crunched all the numbers. SPSS has put out some output. And SPSS has completed its part of this hypothesis test. So what remains now is for us to take a look at this and say, what does that mean? What remains now is for us to take a look at that and figure out what is it that that output is actually telling us. All right, so SPSS is done. And before we can get to step 5, before we can get to our final decision of whether we're accepting or rejecting the null hypothesis, before we can see if that sample t-score is beyond or within the cutoff t-score, we actually have to take a look at the output that we got from SPSS. So I'm going to zoom in on that. We got that right here. And first off, does anybody not have numbers that are approximate to this? Like really close? You could be off maybe on some of these numbers down here, but is everybody close to this? Anybody not close? All right, perfect. Okay, first thing you want to do, as we've seen so far in statistics, it is very, very easy to make a tiny error. It is very, very easy to have a kind of slip of the wrist. It's very, very easy to not highlight all of your scores and copy 8 scores instead of 9 scores. So the first stop you want to do, anytime you do a hypothesis test, anytime you ask SPSS to do something, is check these descriptive statistics up here and make sure that they match with what you have in Excel. So for example, SPSS is telling us, I tested 9 scores. So you want to take a look at that table and ask yourself, how many scores did I have? Yeah, we had 9 monkeys. It said that in the description. Okay, good. I copied and pasted all 9 scores. SPSS will then tell you those 9 scores had a mean of 15.3. And you would ask yourself, is that the right mean? Is that the mean that I calculated in Excel? Oh yeah, that's the same mean. So again, it's just that idea of a double check to make sure that you haven't made any errors. Because SPSS will not let you know. If you copied and pasted 8 scores instead of 9, SPSS will be more than happy to run those scores for you. SPSS also calculated the standard deviation. So again, if we had this information or if we calculated it in Excel, we could once again just double check to make sure that we've copied and pasted the data correctly. All right, so that's our double check. The last thing I want you to also check is that SPSS, very friendly, indicates what test value it used. And you want to check that and make sure that your test value equals your null hypothesis. So this is your last chance to avoid that most common error. So take a look at the output and say, what was my null hypothesis? Time spent with the Terry clock mother was 9 hours. What's my test value? 9 hours. Great. All right. So what we need to do right now, we need to start filling up the information for each of the steps. So we had step 1, we had the null hypothesis, we had the research hypothesis. So what we need right now is we're at step 2. And step 2 is the properties of the comparison distribution. So step 2 is that comparison distribution. We need the mean, we need that estimated standard error, and we're also going to want those degrees of freedom. Those were the 3 pieces of information that we need for our comparison distribution. Thankfully, very nicely, SPSS has given us all that information. So the first thing is that SPSS has given us, or rather given back to us, our comparison distribution mean, because that's the mean of our hypothesized population. That is 9 hours. So that test value, that 9 hours, that's the mean of your comparison distribution. Next thing we need is the estimated standard error. And SPSS has, if you look around, has something up there that says standard error. And this time it's being friendly. That's the standard error that we want. So last time we had to calculate out for ourselves that 1.73. Now SPSS has very nicely done that for us. And then the last thing we need are degrees of freedom. And right now we can do this in our head. Degrees of freedom is 9 subjects minus 1 equals 8. We got 8 degrees of freedom. It gets complicated later on, and for a more complicated statistical test, it gets very hard to calculate degrees of freedom. So very nicely, SPSS has done that for us as well. And it says, there you go, 8 degrees of freedom. So the comparison distribution, we can read that right off of SPSS. We get all of that information from our comparison distribution. All right. Next thing is step 3. And that's your cutoff score. And SPSS will not give you this cutoff score. All right, so this is the one thing that SPSS will not provide for you. This is the one thing that SPSS will not give to you. It will not give you that cutoff score. So you still need to go and look up that cutoff score in your in your unit T statistic distribution. So unfortunately, I don't got my textbook open. So you still have to go to this right here. All right. So you still have to go to this and say to yourself, all right, I'm doing a two-tailed test. I got an alpha level of 0.05. I got 8 degrees of freedom. There is my cutoff score right there. So just make a note of that. I know a lot of students who have gotten frustrated looking for that cutoff score in that SPSS output. It will not give it to you. So just bear that in mind. You got to look for the cutoff score by going to that table A2, cutoff scores for the T distribution. All right. But what it does do, and what it is very friendly with, is it does give you your step 4 sample t-score. So you do get your t-score for your sample. You do get your t-score for your sample mean, and that is listed very nicely right there where it says t. So your t statistic, your calculated statistic for your sample mean, is given to you by SPSS, and in this case, once again, it matches what we did last time. It's 3.637. So now we have all of the information that we need in order to do step number 5. But it's a little bit frustrating, and it won't be frustrating forever, but it's a little bit frustrating right now because we have to look up this cutoff score, right? For our current strategy, the way that we currently do it, we have to look up this cutoff score. And honestly, for me, if you're going to be a statistical package, you should be able to go all the way with your t-test, with your hypothesis test, without having to consult the table. And in reality, SPSS does that for you because what it does is it takes your sample score, and instead of only giving you the sample score, it also gives you the associated probability. So the probability of getting that sample score is right there in that significance two-tailed, and that is 0.007. So I'm going to write that down. That is that p-value. That is that almighty p-value, and it comes up here in this significance two-tailed of 0.007. And the way that this p-value works is that the same way, good luck has been there forever, the same way that when we were dealing with the distributions, for the z-score or for the t-distribution, it's the same idea. The same way that whenever you had an area of the curve, right, for example, 2.5%, whenever you had an area of a curve, that was directly tied to a score on the distribution. So any percentage of the curve was directly tied to a score on the distribution. That we have seen the entire semester. What SPSS is telling you is that this score is tied to this percentage on your distribution. So this is the score that's tied to this percentage here. So why is that important? Well, it's important because now, instead of comparing t-scores, we're going to compare a stand-in for those t-scores, which is proportions, right? So this t-score is compared or tied in directly to this proportion, which means that we can compare our t-scores to that proportion. Because this is what we did. We took a t-distribution, and we said, I'm going to put 2.5% in the one tail. I'm going to put 2.5% in the other tail because my alpha was 0.05. All right, my alpha was 0.05. So I put 2.5% in one tail, 2.5% in another tail, and that gives me cutoff scores of 2.3 and minus 2.3. So 2.3 and minus 2.3. What SPSS has done for you is it has said that your sample, and I'll draw this, I'll try to do it as, well, what would be the best way? Let's get rid of this alpha right here for right now. I'll pop it over here. Alpha, 0.05. What SPSS has said is that your sample is right here, right? Right here at 3.6. That's where your sample is. And that p-value, that probability, that is this part of the curve, right? That is 0.007. And actually, because it's a two-tailed test, it also is the part over here at negative 3.6, because it's a two-tailed probability. But importantly, this is a key thing that I want you to understand. You cannot have a sample score that is more extreme than your cutoff score without having a sample probability that is smaller than your cutoff probability. All right, those things go hand in hand. If your sample score goes beyond your cutoff score, then the probability of that sample is going to be smaller than your cutoff probability. That is just the way that these distributions work. And that opens our door to what we're going to do for the rest of this semester, which is subtly change our decision tree here, where instead of if the sample t-score is beyond the cutoff t-score, we accept the research hypothesis and reject the null hypothesis. And if the sample t-score is within the cutoff t-score, we accept the null hypothesis and we reject the research hypothesis. We're going to keep the logic, but we're going to rephrase it so we can do the whole thing in SPSS. So again, remember, you cannot go beyond the cutoff score without your probability going smaller than the probability in your tails. So we're going to use that and we're going to say, all right, instead of comparing a sample t-score to a cutoff t-score, we're going to compare our p-value, which SPSS will calculate for you. That's this value right here. We're going to compare that to our alpha level, which is given to you in the question. So now you have that alpha level just sitting there waiting to be used. We got that p-value that SPSS has given to us. And because of this relation, if the p-value is less than your alpha, if the probability of your sample in the distribution is smaller than your alpha level probability or alpha level proportion, the only way that could happen is if your sample score went beyond your cutoff score. So we're going to do the same thing we did before if our sample score went beyond. If the p-value is less than alpha, accept the research hypothesis and you reject the null hypothesis. If, on the other hand, your p-value is greater than the alpha level, in that case, you would accept the null hypothesis. Because again, if this probability of your sample is bigger than your p-value here, you cannot do that without your sample not crossing over into that boundary. So just bear that in mind. Reference these as well. So if the p-value is greater than the alpha level, accept the null hypothesis, and we reject the research hypothesis. And now we can do the whole thing from this output right here. Because this is our p-value. This significance two-tailed, that's what it is. All right? SPSS doesn't call it a p-value. That's our p-value. That's the probability of getting a sample this weird if the monkeys did not prefer the terry cloth mother. So we compare that, 0.007, we compare it to an alpha of 0.05, and we take a look at our decision tree, and we say 0.007, that p-value is less than an alpha of 0.05. So we decide to accept the research hypothesis and reject the null hypothesis. And that brings us to our final conclusion, where we reject the null hypothesis and we conclude that that monkeys actually prefer the terry cloth mother. So before we wrap up this first look at SPSS, I'll just tell you one last thing. If you are unsure about comparing your p-value to your alpha value, two things I want you to do. If you're unsure about comparing your p-value to your alpha value, consult these two slides. All right, the same way that you were doing it before with the cutoff score and the critical value, consult these two slides and make sure that you are making the right conclusion. All right, so do that, get practice with p-values and alpha values, but also, especially in the beginning, check it against your sample score and your cutoff scores. So take that extra step, look up your cutoff scores. And if you're doing it correctly, you should come to the same conclusion both times. If your p-value is less than your alpha level, then your sample score will be greater than your cutoff score. If your p-value is greater than your alpha level, your sample score will be less than your cutoff score. Basically, make your decision based on p-values and alpha levels. Make your decision based on sample t-scores and cutoff t-scores, and you will end up, if you've done it correctly, with exactly the same answer. All right, yep.
So really the only reason for us to use the p-value and the alpha value is just because it's more convenient with the SPSS program, correct?
Yeah, because it's there. Yep. And this is actually, part of the reason is because it's there. It's like a one-stop t-test. Second reason is because this is the way that most psychologists will do it. Okay. And then the third reason is that when you report statistics, and this is an APA issue, when you report statistics, they want to know that p-value. So when we do it with a cutoff score, we can say that the p-value is less than the alpha level, right? But we don't have that exact p-value. And we might not be able to find it in our table, but they want to know it. So that's also why we kind of rely on p-values as well. All right, so the monkeys prefer the cherry cloud mother. And that is your taste of SPSS. So a couple of things to clear up or to do before we have our practice time. It's going to be a little bit shorter today, but we needed to take our time here. First off, keep up with the MyStatLab study plan. And for everything that we do, I mean, work on your mastery points, but for everything that we do from here on in, you're going to be able to do it on SPSS. And getting familiar with SPSS, being able to use SPSS is part of the requirement and learning objectives of this course. So I highly, highly recommend try to do this, anything that you can with SPSS. So if you haven't already, make sure that your IU Anywhere access works from whatever computer you're going to use, because sometimes that Citrix receiver gets a little tricky to set up initially. Once you got it set up, you'll have no issues. But make sure that that's set up so you can do your homework from the comfort of your own home, on a Friday night. Number 2, try to use SPSS for whatever it is that you're doing. That includes pre-tests. So when you read through the chapter, when you're taking a look at the information there, especially for independent means t-test, that's coming up in the next chapter. But when you read through it, you'll see the multitude of steps and the multitude of calculations you need to do by hand. That's fine if you want to do it that way, but don't forget that there are tons of resources on how to use SPSS. The point of the pretest is to get you familiar with the information, familiar with the ideas, in order that you can do the pretest as you come to class prepared. I have no issues whatsoever if you go to YouTube, type in independent means t-test, SPSS, and follow that 5-minute tutorial video on how to do that t-test for your pre-tests, okay? So we will definitely cover SPSS in class, but just so you know, you have options. You can either spend 45 minutes calculating these by hand, or you can spend 5 minutes watching that video and 2 minutes calculating it with SPSS. It's up to you. I'm fine either way, but just so that you're aware of those options. All right, last thing, we do have extra practice. There's no homework coming up. Do double check the syllabus, but I'm pretty sure that we need to cover at least one more thing before we get into that second level of homework. But we have some extra practice that you can use to kind of get familiar with SPSS for this single sample t-test. So the questions, the raw data is available in the same Excel sheet. So there's one question on birds. There's one question that has to do with children. There's a question on senses of humor. So all of these are available. The raw scores are available there in the Excel sheet. But very importantly, the solutions to these are available in the questions and the solutions are available in a separate PowerPoint file. So what I would highly recommend is read the question, try to do it on your own. Run it through SPSS, follow the notes that we did today, the notes that you made for yourself. Try to do this on your own and pay particular attention to the information that is given to you to help you figure out that null hypothesis. Okay, so again, look for those instances of what would be true if there was no effect. What would be true if there was no preference? What would be true if, if that's the case? And then what these PowerPoint slides have is they have your output that you should get for each of these questions, so you can double check your calculations across those outputs. And then what you want to do is you want to, very much like what we did here, come up with step 1, what is the null hypothesis, the research hypothesis? Step 2, what is the mean, the standard error, and the degrees of freedom for the comparison distribution? Step 3, what is our cutoff score or cutoff probability? Cutoff probability is super easy, it's your alpha level. Step 4, what is your sample score and your sample probability? Step 5, do we accept or reject the null hypothesis? Try to do that on your own, and then double check it against the answers that are provided on that third slide. So you have that for every single question, okay? But I highly recommend when you're doing this practice, try it on your own. Try to do it without checking the answers first. Try to go through the whole process, get all the steps done, and then double check your answer as we begin our practice for SPSS. All right, so that is it for today. So we have not that much time left. We got a little bit of time left. So if you got your SPSS open and you want to start on some of these demo practice questions, feel free. If you want to call it a day, feel free as well. And I highly recommend, as we're going forward, just one more time I'll mention this, try to use SPSS as much as you can, because it is a highly powerful data statistics editor. It will save you tons of time, and it's just part of the learning process of this course. So do try to use it whenever you can. And other than that, we are done for the day.